Hello everyone, myself Kiran Kadakuntla, lecturer, Department of Electronics and Communication Engineering. Today we are going to discuss session 4 of unit 1, that is parameters of rectifiers. Okay, so in the previous session, that is session 3, we have discussed about the full wave rectifiers. Okay, so in full wave we understood what is mean by full wave rectifier. Then in full types of full wave rectifier like center tap full wave rectifier and bridge type full wave rectifier. Okay, in that we have seen in the center tab full wave rectifier, what is the circuit diagram, how it works, what is the output waveform, and its related parameters like what is the ripple factor, what is the efficiency, and other related parameters of center tab full wave rectifier. After that, we have discussed about the bridge type full wave rectifier, and in that concept, we understood so why it is called as bridge type full wave rectifier, what is its circuit diagram, what is the output waveform it will be getting, okay, and it's related the parameters like ripple frequency, efficiency, PIV, okay. So these are the things we have discussed in the previous class, and at the last we have discussed some questions based on those topics. So today we are dealing with the parameters of rectifiers. Okay. So in the previous class also we have seen some parameters, but there we just seen the parameters. We are not derived it. In this session we are going to understand how we are going to get that values. Okay. So these are the topics we'll be covering today. We'll be understanding the parameters of half wave rectifier and full wave rectifier. So we already know the value of parameters of half wave and full wave, but we don't know how we get that value. Okay, so today's session we are going to cover that. Okay, so let us see the parameters of half wave rectifier here. So in the earlier session also we have discussed what is mean by average value or DC value, what is mean by RMS value and peak value. Okay, so we'll see the value for half wave rectifier. Average or DC value of load current, that is IDC, of half wave rectifier is Im by pi. What is Im? It is a maximum current or peak current. Okay, so output of the half wave rectifier, in that if you want to get the average load current, that is IDC, the equation is maximum current divided by pi. Okay, then RMS value of load current. Suppose we want RMS value of the load current, that is IRMS, it is denoted as IRMS, means root mean square value of current. Okay, so this is given as Im by 2. Im means it's a maximum current or peak current divided by 2. By this we'll get the RMS value. Then comes peak inverse voltage, that is PIV. So we already discussed what is mean by PIV. PIV means it is a maximum reverse voltage that can withstand by the diode, or the maximum reverse voltage what we will apply. Okay, that is a peak inverse voltage. In this, it's a half wave rectifier. So what is the maximum reverse voltage what we can apply is a VM, because we know the output of the half wave rectifier where we have only half the waves. Okay, so peak inverse voltage will be VM. Then come ripple factor. Okay, so we discuss what is meant by ripple factor. Ripple factor means it shows the amount of ripples present in the output of the rectifier. Okay, so that is a ripple factor, and the value of ripple factor for a half wave is 1.21. You can see here we have a more ripples in the half wave rectifier. Then comes ripple frequency, means we know that rectifier output is the having the ripples. Okay, we'll be checking the frequency of the, those ripples, that is a F in, means this frequency is equal to your input frequency. That means suppose if it has a 60 hertz input frequency, the output of the half wave rectifier also a 60 hertz. Okay, because it has a ripples, but input will be AC and output will be DC. Okay, then coming to efficiency, that is eta. Efficiency is 40.6%. Since it is giving the output only for the half of the input signal, so you can see the efficiency is very less, that is less than 50%, and it is 40.6%. Okay, so these are the parameters of half wave rectifier. Okay, these are very important. you must remember these values. Okay, and these values is going to differ from half wave to full wave. Okay, you cannot have a same value for both the rectifiers because of its difference in the operation. Okay, both are operating in a different way, so we cannot have the same value. So these are important in the point of view of examination, or even when you're solving some problems, you must remember these equation to solve the problem. Okay, okay, now we will understand ripple factor of half wave rectifier. So we already understood what is meant by ripple factor. Even we have discussed what is the value of half wave rectifier, half wave rectifier's ripple factor. Okay, that is 1.21. Okay, this is we already discussed, but till now we have not understood or gone through the derivation of getting this value. Okay, how we got this value. So now we are going with the derivation to understand how we will get the ripple factor of half wave rectifier as 1.21. Okay, so to understand this derivation, you must remember the ripple factor equation. This we have discussed in the earlier class. If you remember, is good. If you don't, just you can go back to the earlier session and you can go through it. Okay, this is the equation of a ripple factor, and then independently we need to remember the equation for IRMS and IDC. Just now we have discussed. So even if you want, we'll go back to that screen and we can see it again. So for IRMS, this is Im by 2, and for IDC it is Im by 5. Okay, so these are the equations very much essential to solve that or find out the value of a ripple factor. Okay, so coming to this derivation, we have the equation. The formula for ripple factor is, this is gamma equal to square root of IRMS divided by IDC whole square minus 1. This is the equation for ripple factor, and we need to identify the ripple factor for the half wave. That means we need to substitute the value of IRMS and IDC of a half wave rectifier. So we know that for half wave rectifier, IRMS, okay, that is root mean square current is given as Im by 2. Im means it's a maximum current. Okay, then IDC means DC current, and DC current is given as Im by pi, means maximum current divided by pi. So now we have a equation for IRMS and IDC. We are going to substitute these two values in the equation 1. Okay, so substituting equation 2 and 3 in equation 1, gamma equal to square root of IRMS is given as Im by 2. So we written Im by 2 divided by IDC. IDC means Im by pi whole square minus 1. Okay, so we are just substitute the value of IRMS and IDC. We got this value. So now our work is to just simplify it. So how you can simplify this? You can see here in both the numerator and denominator we have a Im and Im. It will get cancelled, and this root 2, this 2 is comes into denominator, and this pi is the denominator of the denominator. Okay, this goes to the numerator. Okay, simple calculation. So since it is having whole square, both will be squared. Pi goes to the numerator and it is a pi square. 2 comes to the denominator and it has a square, so 2 square will be 4. So this is this simplification will be pi square by 4 minus 1. Okay, so it's a simple one. If we calculate this, it will come out as 1.21. So this is how we get a ripple factor of a half wave rectifier as 1.21. Okay, so just you need to remember these three equations and you'll get the answer. Okay, so just go through this. Okay, okay, if you understood this, then we'll move on to the next slide. Okay, now we are dealing with the efficiency of half wave rectifier. We have discussed what is meant by efficiency, and we have discussed the value of efficiency of a half wave rectifier. So what is efficiency? It's a output power by input power. And what is the value of efficiency of half wave rectifier? It is 40.6. Okay, we have discussed it many times. So we have a efficiency of 40.6 percentage, and now we are going to derive that and we are going to get that value. Okay, so here also we need to remember few equations. So efficiency of a rectifier is given is with this equation. This is also we were discussed in the earlier sessions. So if you have understood that, that's good. If you're not, then you can go back to that session. First try to understand those concepts, okay, and you can understand how we get this value. Then you can come back to this session and you can continue this, okay. So here once again we have a equation, eta is equal to IDC, DC current divided by the root mean square current whole square, okay. So this is the equation, and since we are calculating the efficiency for half wave rectifier, we need to substitute the value of IDC and IRMS of half wave rectifier, okay. So what is the equation for IDC? So just now we have seen the IDC equation for half wave rectifier is Im by pi. Im means maximum current. Then IRMS means root means square current of half wave rectifier is given as Im by 2. Once again, Im means it's a maximum current. So we have the equation value for these two equations. Okay, IRMS and IDC. We are going to substitute these two value in the efficiency equation. So let's do that. It's a eta efficiency equal to, so IDC will be substituted with Im by pi. Okay, we have Im by pi, and IRMS is substituted by Im by 2 and whole square. So let's solve this. In both the numerator and denominator we have Im and Im. It will both will get cancelled, and this pi is in denominator, so it comes to denominator, and this 2 is a denominator of a denominator, so it will goes to the numerator. So this pi, it is whole square, so 2 become a 4 and pi become a pi square. So total value will be 4 by pi square. If you calculate this, it will come out as 0.406, and normally we express the efficiency in the form of percentage, okay. So when you calculate it in percentage, it will come out as 40.6 percentage, okay. So it's very easy. Just you need to remember the efficiency equation and IRMS and IDC values, okay, with respect to Im. Then just substitute it and you will get the value, okay. So this is a efficiency of half wave rectifier. Just go through this. Okay, so we'll move to the next topic. Now we'll understand what are the advantages of half wave rectifier and what are the disadvantages of half wave rectifier. So can we guess what are the advantages of half wave rectifier? So if you remember the structure of the half wave rectifier, then you can express its advantage and disadvantage, okay. So let's go with the advantage. So what is the main advantage of for half wave rectifier? It is using only one diode, okay. So it is using only one diode, that's the biggest advantage, okay. Then the circuit is simple, and it is center tap transformer is not required, okay. So here we will not be using the center tap transformer. In full wave we will be using the center tap transformer, okay. So it is cheaper. So these are the some advantages of a half wave rectifier, okay. So these are the advantages. Let's go with the disadvantages of half wave rectifier. So disadvantage is what? The mainly it has a more amount of ripples and less amount of efficiency. That is the main disadvantage of a half wave. Okay, and let's go with the given statement. It only allows a half cycle of input signal, and the other half cycle is wasted. This leads to power loss. So it deals with the power loss. You can understand that since half wave is dealing with only half of the input signal, that means it is not utilizing the other half of the input signal. So directly we are wasting our 50% of the input signal. Okay? So this leads to a power loss. It produces a lower output voltage, obviously, because out of the two positive half cycles, half cycles of AC input, that is positive and negative, we are taking only positive. That means obviously we are going to have the lower output voltage. So this is one more disadvantage. Then output current. So just I'll move my video here. Okay. The output current we obtain is not purely DC and it still contains a lot of ripple. That is means it has a high ripple factor. So you can see that the output is not having the pure DC. We know that it has a ripples. So the ripple factor will be very high. So just now we have seen the value of ripple factor. What is the value? It's a 1.21. It is higher. So this is one more disadvantage of a half wave rectifier. So just go through this half wave rectifier advantages and disadvantages. Okay, move to the next topic, that is a parameters of full wave rectifiers. Okay, so just now we have seen the parameters for half wave rectifier. Now we are dealing with the parameters of full wave rectifier. Okay, so here average or DC value of a load current. So average value or DC value of a load current is given as IDC is equal to 2 Im by pi. Okay, so this is 2 Im by pi. What is meant by Im? Im means it's a maximum current. Okay, now RMS value means root means square value of a load current. IRMS is equal to Im by root 2. Okay, so this is the RMS value of a full wave rectifier. And peak inverse voltage PIV means peak inverse voltage means maximum reverse voltage can be applied. Okay, so it is a 2 Vm. Remember in a half wave it was only Vm and it's a 2 Vm. So ripple factor is 0.48. Ripple frequency is 2 times the input frequency. So you can observe here the ripple here has gone down compared to your half wave, and the output ripple frequency is double the input. In half wave it was only similar to your input frequency. And the more importantly, the efficiency of a full wave rectifier is 81.2, whereas in half wave it was having the 40.6. Okay, after this slide we are going to deal with this, how we will be getting the 0.48 and 81.2 percentage. Okay, so these are the parameters you must remember regarding the full wave rectifier, and these equations are also very important. So as you already seen the half wave rectifier, we are going to derive the ripple factor value and efficiency value by using these values, average value and RMS value. So remember these two equations. So if you have understood the calculating the ripple factor and efficiency of a half wave rectifier, even you can try calculating the ripple factor and efficiency of a full wave rectifier. Just you must remember the ripple factor equation, and then you need to substitute these IDs and IRMS to calculate the ripple factor. Similarly, if you want to calculate the efficiency, first you must remember the equation of efficiency, then value of this IDs and IRMS. So substitute that, then you will get this value. Okay, it's very easy to do it, just provided you must remember some basic equations. Okay, so if you remember that, even you can solve it easily. So these are the parameters. Let's move to the next slide. Okay, in this slide, we are going to calculate the value of ripple factor of a full wave rectifier. Okay, so let's go with this. First, this is the ripple factor equation. Gamma is equal to square root of IRMS divided by IDC whole square minus 1. This is the main equation. And now we need to substitute the IRMS and IDC of a full wave rectifier. We need to substitute that. Then we are going to get the value. So IRMS is given as Im by root 2. IDC is given as 2 Im by pi. Okay. So Im means what? It's a peak value of a waveform. Now we are going to substitute these two values in this equation. So IRMS is given as what? Im by root 2, and IDC is given as 2 Im by pi. Okay. So we have substituted these two values in the equation number 1. Then we have this equation. Now we are going to simplify this. In a numerator and denominator, we have a Im and Im. This will get cancelled. And this root 2 is a denominator. So it will come here. Then this pi is a denominator of a denominator. This will goes to the numerator. So when it goes to anyway, IM is get cancelled. This pi goes to the numerator and it is squared. So it's a pi square. This root is the denominator. It comes to the denominator section. That will be 2 into root 2 of whole square. So remember 2 into root 2 of whole square. If we simplify this, that root 2 square means it's a 2 and square of a 2 is a 4. Okay. So that will be a 4 into 2. That will come out as 8. So simplification of this entire part will be pi square divided by 8 minus 1. So if you calculate this, it will come out as 0.482. This is a ripple factor of full wave rectifier. So if you, do you remember what is the ripple factor of a half wave rectifier? It is 1.21. It is much more than the this full wave rectifier. So it shows that we have very much less ripple in the full wave rectifier output. Okay, so this is the biggest advantage of full wave rectifier compared to our half wave rectifier. Okay, so just go with this derivation, then we'll move on to the next topic. Okay, let's move to the next topic. Now we'll understand efficiency of full wave rectifier. Okay, full wave rectifier efficiency. So once again here also we already know the value of efficiency of full wave rectifier. Now we are going to derive it. First coming to the efficiency equation, that is eta is equal to IDC divided by RMS whole square. Okay, this is the equation we have discussed earlier sessions. Okay, just we are going to use this. And here we have a IDC and IRMS. IDC means it's a DC current. IRMS means it's a root mean square current. Okay, so we are going to substitute these values in this equation. IRMS is given as Im by root 2 and IDC is given as 2 Im by pi. So substitute these two in the given efficiency equation. Eta is equal to, here it's IDC. IDC is given as 2 Im by pi. Okay, it's given in the numerator, and IRMS in the denominator, it is given as Im by root 2, and it's a whole square. Okay, let's simplify this. Here we have a Im, and here it's Im. Okay, so Im get cancels. This pi is a in numerator, sorry, denominator. It will come to denominator, and this root 2 is the denominator of the denominator goes to the numerator. So now this pi, it's a whole square, so pi will become a pi square, and here in the numerator it will be 2 into root 2 whole square. Okay, so if you simplify that, it will be 8. So total value when you calculate this 8 by pi square, it will be 81.2 percentage. Okay, it will be 0.812. When you calculate it in terms of percentage, it will be 81.2 percentage. Okay, this is the efficiency of full wave rectifier. Okay, just go through it. Okay, now we will understand. We have seen the ripple factor of full wave rectifier and efficiency of a full wave rectifier. Now we will understand the advantage and disadvantage of full wave rectifier. Okay, so first we are going to understand or discuss the advantages of full wave rectifier. Then we will discuss the disadvantage of full wave rectifier. Coming to the advantage, what is the bigger advantage is its efficiency. So just now we have seen its efficiency is 81.2. Okay, so very good efficiency. In a half wave, it was only a 40.6, less than the 50%. So the first bigger advantage is efficiency is higher, and the ripple factor is less. Means number amount of ripple present in the output will be very less compared to your half wave. It's a bigger one more advantage. Then DC load voltage and current are more than the half wave. So when you compare with the half wave, we have a very high DC load voltage and current. That means if any application requires higher voltage and current at the output side or to the load, then we must refer the full wave rectifier. Okay. So even it has some advantages, it also has some disadvantages. Like if you are using the center tapped full wave rectifier, you must need a center tapped transformer, which is costly. Okay, so it is costlier. So it is a one more disadvantage. It is in the case when you are using the center tapped full wave rectifier. Even here we have not mentioned that. That is a, if you are using the bridge type full wave rectifier also, then that will be using the 4 diodes. Okay, whereas in half wave we will be using only one diode, and in bridge rectifier we will be using 4 diodes. Okay, that is, you can say, one more disadvantage. Then the PIV rating of a diode is higher. Okay, since the full wave rectifier is dealing with the higher voltage, even for the center type of full wave, we have seen that the PIV is given as 2 VM. Okay, so it is higher. So this is the disadvantage of full wave rectifier. So this is the chart which will gives the complete picture of our rectifier types. Okay, so just I'll make my video side so that you can easily see this complete chart. Okay, so if you remember this chart, more or less you almost covers the types of rectifier. Okay, so in this it is dealing with all the particulars or all the parameters, and it gives the values for the half wave, full wave. That is full wave. In this case, full wave means it's a center tapped full wave, and the bridge means it's a bridge type full wave. Okay, don't get confused. Okay, these both are full wave. It is center tapped and it is a bridge type. Okay, let's go with one by one. So number of diodes usage, we already know half wave is using only one diode, and full wave is using two diodes, and bridge is using 4 diodes. So maximum efficiency what the rectifier can achieve is 40.6 in the half wave and 81.2 in the both the center tapped and the bridge rectifier. And the ripple factor for half wave it is 1.21, and full wave and bridge type it is a 0.48. You can observe here the ripple is very less in the full wave. And peak inverse voltage for half wave it is Vm, full wave it is center tapped full wave it is 2 Vm. Okay, and bridge once again it is a Vm. VDC output when there is no load is connected, then it is given as Vm by pi, and for full wave both center tapped and bridge it's a 2 Vm by pi. And output frequency will be, for half wave it is similar to your input frequency. For full wave it's a both will be having the double the input frequency. Okay, 2f. And average current per diode is a IDC, and here it is a IDC by 2. Okay, so this is a complete chart of comparison of half wave and full wave rectifiers. Okay. So if you've gone through this chart, you will cover all the parameters regarding the rectifiers. Okay, I hope you understood these all topics. Okay, so if you have cleared the topics regarding the rectifiers, then we'll go to some questions related to this. Try to answer the question. Okay, so if you are able to answer the questions, then that means you understood the concepts correctly. Let's go with the questions. So we'll deal the multiple choice questions. The first one, the average or DC value of a load current for half wave rectifier is given by. So this is the, in the same session we have discussed. Initially, we have seen what are the values for the average or DC value of a load current for half wave rectifier. The options given are IDC is equal to Im by pi, and second option IDC is equal to Im by 2 pi. Third option IDC is equal to 2 Im by pi. Fourth one is a none of the above. So try to answer this question. So do you remember what is the equation we have discussed? This is the topic we have discussed today, and we have seen the equation. So which one is the correct answer for this? That is the first option, IDC is equal to Im by pi. That is the correct answer. Okay. So let's move on to the next question. Just I will set it back. Fine. Now, second question is given as the RMS value of a load current for half wave rectifier is. RMS value means root mean square value of a load current, that is IRMS of a half wave rectifier. The option given are Im by root 2, Im by root 4, sorry, Im by 4, Im by 3, and Im by 5. So, okay. So, 4 options given here for the given question. So, try to answer it. Okay, correct answer for this question is, that is Im by 2. Okay, the option A is a correct answer for the given question. Let's move to the next question. Okay, third question. The question is average or DC value of a load current for full wave rectifier is. So now it is dealing with the full wave rectifier. The earlier two questions was based on the half wave rectifier. Now it is based on the full wave rectifier. The options given are, first one 2 Im by pi, second is a 0, third one is Im pi, fourth one is a none of the above. So can you answer this? Okay, so correct answer for this question is option A, that is 2 Im by pi. Okay, so this is the average or DC value of a load current for full wave rectifier. Next, fourth question, RMS value of load current IRMS for full wave rectifier. Okay, so here just go back to the earlier question. It was dealing with the average or DC value. Okay, now we are dealing with the RMS value of a full wave rectifier. So RMS means root mean square value. The available options are Im by root, Im by 2, Im by 4, 2 Im by root 2, then Im by root 2. So which one is the correct answer? Okay. So you might have already got the correct answer. That is a option D, Im by root 2 is the correct answer for this question. So last question for this session, that is the PIV for full wave rectifier is. Okay. So peak inverse voltage for a full wave rectifier. So it mainly full wave means it is dealing with the center tapped full wave rectifier. The available options are VM, 2 VM, 4 VM, VM by 2. So which one is the correct answer? So just now we have seen the table. There also we have mentioned that in a full wave center tapped full wave rectifier has a PIV of 2 VM. Okay. So correct answer is option B, 2 VM. Okay. So this is the answer. So we are coming to the end of this session. So what are the topics we have discussed? Just we'll revise it. We have discussed that what are the parameters of a half wave rectifier. It may be IRMS value, IDC value, then ripple factor, efficiency, PIV, output frequency. Then we have derived the value for ripple factor of a half wave rectifier and efficiency of a half wave rectifier. Okay. After that, we have discussed the parameters of full wave rectifier, that is IRMS value, IDC value, ripple factor value, efficiency value, PIV value, then the output frequency value. Then we have derived the expression for value for ripple factor of a full wave rectifier and efficiency of a full wave rectifier. After that, we have seen the chart or the table where it has all the values consolidated, and it has it's given the complete comparison of half wave and full wave. In a full wave, it has a two section, that is a center tapped, and one more is a bridge type full wave rectifier. Okay. So after that, we have gone through some questions and try to answer it. Okay. If you are able to answer those questions, that means you understood the concept clearly. If you are having any problem in answering those questions, just you can go back to this video again, see the video again with the explanations. Okay. Then you can answer it well. Okay. Thank you. We'll see the next, we'll meet in the next session.